Welcome to this workshop on GRE math or quantitative strategies. I'm James Powell. I work here in Hill Hall on the campus of Winston-Salem State University. I am glad you are with me. And let's just jump right in. So in previous weeks, I've talked a little bit about the GRE verbal component as well as the GRE writing component. Today, we're going to lock in on the math component. And specifically, I want to talk about the quantitative comparisons, because based on my experience, this is the most difficult aspect of the math section. So I'm going to dive very deeply into it in the hopes that I will help to show you how to deal with this most unique and most interesting piece of it that you're probably least familiar with. So I'm going to hit that pretty hard so that we can get better at something that is very foreign to us. So as you know, the GRE is the graduate admissions exam, and it does have three major components, which are shown here on the slide. We're going to talk about the quantitative reasoning portion here. And you can see there are 20 questions per section, 35 minutes per section. You can easily find that information on the website ets.org. So without any further ado, let's dive into that math section. And again, specifically the quantitative reasoning, which I will define shortly. But I want to first start by giving you four main strategies to use. These four must be used in conjunction. The first one is start with what you know. For many of these questions, there's going to be a given. In other words, they're going to give you some information that you're going to start with. And that information you must break down, analyze, understand. Start with what you know, and oftentimes that means start with what you're given. Number two, a lot of what you're going to do in quantitative reasoning will require you to put in numbers for variables in order to see what works and what doesn't. And so my second recommendation, my second strategy for success is to pick easy numbers. So easy numbers are numbers that are easy to work with. Sometimes these will be things like -1, 0, 1, 2, 100. Those will be the first ones that come off the top of my mind as to easy numbers to work with. However, it is going to depend largely on your question. For example, if your question involves other given numbers that they've already assigned to you, like the number 33. Well, if they give you the number 33 for some aspect of the question, then maybe -1, 0, 1, 2, 100, maybe those are not the best numbers to use. Maybe the number 3 is a better one to use, or the number 11 is a better one to use. Why? Because those are factors of 33, right? They'll divide evenly into 33 to give you a whole number. So you always want to be thinking about, given this specific problem, what is considered an easy number. The third thing I want you to consider is think in terms of range of values. This is part one of 2 slides. This first slide shows you one example of what a range of values could be. I want you to look at the very, very low side, and I want you to look at the very, very high side, and even the max side, to test all the flavors of what these numbers that you're picking could be. For example, if you pick the number -1 and you run the numbers and you see what happens. Next time you pick the number 1 and you run the numbers and see what happens. Next, I want you to pick something at the max level. For example, 100 or 1000, something that is still within the range, but allows you to really test the effects of your variable. Again, all of this will be much more clear once we jump into our first question, which will be in about 3 minutes. But first, let's look at another way in which you can evaluate ranges. I've shown this, this long jumper to illustrate for you, again, this idea of range. I want you to go from the smallest possible point to the largest possible point whenever possible. And finally, this is the last strategy before we dive into the questions. You must ask yourself, is the answer sometimes A or sometimes B? And if so, then the actual answer that is correct is going to be D, which represents cannot be determined with the information given. All right, so this is very critical. If sometimes column A is the biggest and sometimes column B is the biggest, the right answer is D, cannot be determined with the information given. All right, so I know this is all a bit cryptic, a bit mysterious, but we're going to get all those questions answered promptly. We are now getting into the quantitative comparison. First, these are general math guidelines that they're going to have on the test. And you'll notice that it does talk about how you should be careful because some of these figures are not necessarily drawn to scale. So you cannot assume that certain quantities are as they appear in the figure. And this is very important for quantitative comparison. They are only estimations. They are not necessarily drawn to scale. All right, now let's get into the directions for quantitative comparison specifically. It says for each of these questions, compare quantity A and quantity B using additional information centered above the two quantities if such information is given. Select one of the following 4 answer choices and fill in the corresponding oval to the right of the question. A, quantity A is greater. And what they don't say here is quantity A is greater all the time. So I want you to psychologically, mentally remember that A is when it is always, all the time, A is greater. Likewise, you're going to circle or fill in answer choice B if quantity B is always, all the time, greater. Same thing for option C. You're going to only fill in that answer if the two quantities are always equal. Finally, you're going to fill in answer choice D if the relationship cannot be determined from the information given. All right. Finally, they do mention that a symbol that appears more than once has the same meaning. It just means the symbology is consistent across each question, if they even use any symbology, which is going to be pretty rare anyway. So now they give you some examples, and they will do this on the test day. They will show you an example or two, and it will show you that quantity A is 2 times 6 in example 1, and quantity B in example 1 is 2 plus 6. So you have to decide which is always greater. Is A always greater? B always greater? Are they always equal? Or can you simply not determine it? Meaning sometimes A is bigger and sometimes B is bigger, just like I told you in my strategy number 4. So for example A, clearly 2 times 6 is 12. 2 plus 6 is 8. 12 is always greater than 8. The answer is A. Let's look at a second example. Quantity A is the line segment PS. Quantity B is the line segment SR. But there is no other given information aside from this set of triangles that, as we mentioned, is not necessarily drawn to scale, okay? Keep it in mind. It is not necessarily drawn to scale. So you cannot simply use your fingernail or use a pencil tip and examine how long that particular segment is and compare it and say, oh, is it equal or not? No, that's not what we're doing. If you're not given numeric information, you cannot estimate with your pencil or your finger to try to approximate the distance. That is not what quantitative comparison is about. So indeed, because there is no given numeric information, there's nothing to work off of. So the correct answer is I cannot decide, because I can imagine a case where PS is bigger, and I can imagine a case where SR is bigger. All you have to do is have a range, right? We talked about ranges. Have a range of possibilities in which PS is bigger. Of course, you can think of PS equals 20, SR equals 10, to use simple numbers. You can also think of a situation where B is bigger than A. Why? Because there is no numeric information. You get to choose whatever comes to mind. And in my mind, I can say SR is 30 and PS is 1. Therefore, SR is bigger than PS, given the numbers I picked. And again, they've given me no restraints, no constraints, nothing to stop me from picking whatever I like. Now, obviously, these are very easy questions. They're going to give you harder questions where they give you parameters or constraints. And then you still have to be able to work in those constraints to come up with possibilities within the range. But here, no numbers are given. We can pick whatever we like. Clearly, it's possible for PS to be bigger than SR, and clearly, it's possible for SR to be bigger than PS. Now we'll get into the real stuff. Here's a real question. It's time for us to practice. Here's one of maybe 7 or 8 questions. What I'm going to do is I'm going to read off the question. I'm going to let you think about it. You can pause the video, figure out the solution for yourself, or give it a try for about 2 to 3 minutes, or you can take longer if you need to, between 2 to 5 minutes, depending on what you prefer. And then you can restart the video and watch how I break it down. So here's the question. Again, feel free to pause and read it by yourself and figure it out by yourself without looking at my yellow highlighted clues. So you've got a circle. O is the center of the circle above. That's the given information. You also have numeric data. So you have to look carefully at the figure to see where the 3s and 4s are at. So the question is basically saying, is quantity A of X always greater than quantity B, which is 5? Or is quantity B always greater than A? Or are the two quantities equal all the time? Or is it sometimes A, sometimes B, in which the answer is D, like I've told you before? So go ahead and pause the video now and try to answer the question yourself. Give yourself between 2 to 5 minutes. And now I'll get into my breakdown and analysis. So for every question, you need to always ask, is A always bigger than B, or is B always bigger than A? So my hint to you here is use the Pythagorean theorem, right? That means one side of a right triangle squared plus the other side of a right triangle squared equals the hypotenuse squared. There's also something very specific, a very specific kind of right triangle called a 3, 4, 5 right triangle. And that's something you should memorize, okay? Memorize. You should know that there is such a thing as a 3, 4, 5 right triangle. And so what that means is automatically, if the two legs are 3 and 4, or if you know any two of these pieces of information, you know the third is definitely true. So if you know that one leg is 3, the other leg is 4, you know the hypotenuse is 5. Or if you know the hypotenuse is 5 and you know that one leg is 3, you know the other leg is 4. This is a certain truth. As long as it is a right triangle with 2 of the 3 elements, the third element must be true. So if you were to diagram this, you will see that below point 0 or point O, below the middle of the circle, you can tell that the hypotenuse, the two legs are 3 and 4, and it is indeed a right triangle. Therefore, that hypotenuse, which is the radius, is equal to 5. So the hypotenuse is 5, therefore the radius is 5, because by definition, it connects the midpoint of the circle to the very edge of the circle. And therefore, the other hypotenuse of the other triangle is also 5. And if we know that one leg is 3, hypotenuse is 5, we know the other leg is 4. So quantity A, which equals X, equals 4. X equals 4. So we've now determined quantity A, X, equals 4 all the time. It's a static number. Quantity B equals 5 all the time. It's also a static number. And therefore, which is greater all the time? A or B, or are they equal, or can you not determine it? The answer is B. This is ranked a 65%, meaning 65% of the people got it right. I would consider this an easy medium question. Next is question number 2. You've got these two runners. And again, you must consider the given information and fully understand it first. So one runner, A, ran 4/5 of a kilometer, and runner B ran 800 meters. Immediately, you have to start thinking, what is a kilometer as compared to a meter? And if you stop and think, kilo means 1,000. So kilometers are 1,000 meters. 4/5 of a kilometer means 4/5 times 1,000 meters. So 4/5 times 1,000 is 800 meters. So you should be doing these calculations even before you think about the answer, the quantity A and quantity B. So what you've determined is both runner A and runner B both ran 800 meters. They ran the same distance. So now looking at A and B, A is the distance that A ran, B is the distance that B ran. We know now that they are both 800 meters. So the answer is always equal C. All right, this is an 83% of the people got it right. Therefore, this I would consider to be an easy question. Hopefully you got it right. Now let's go to question 3. Again, you can pause at any time and just look over the question yourself before continuing if you want to stop and not listen to my explanation. So now's the time for you to pause the video, look at the question without looking at my yellow highlights, and try to answer it. I'm assuming now you wish to hear the answers, so let me describe how to analyze this. Again, you must take your given information as gospel. It is the truth. X must always be less than Y, which always must be less than Z. So I know that they're going to be sequential, if you will. So now you need to think in ranges, which is my first bullet point. What could X, Y, and Z be equal to? Once you've come up with a good set of numbers, then find a different, more extreme in the range possibility. For example, I just came up with these myself. What if I chose 1, 2, and 3, right? X is 1, Y is 2, Z is 3. Very, very simple. The good thing is I'm also looking at my question. I'm making sure that my sum is divisible by 3, right? Because you see the quantity A is dividing stuff by 3. So I make sure my 1 plus 2 plus 3 is divisible by 3, which it is, because it is X plus Y plus Z equals 6 divided by 3 is 2. Quantity A is 2. Quantity B is 2 in my first example. Therefore, they are equal. However, that does not mean the answer is C. We've only done one testing, one range of values. We now need to test a second range of values. And if we're still not happy, possibly even a third range of values. But let's start with the second range of values. So now I'm going to just change it up. I'm going to pick a negative just for fun. I'm going to pick a 0 value just for fun, just to make it different. And then I'm going to pick something that's real big, right? But it still has to be small enough to work with. And I also want to make sure that my sum is divisible by 3. So I pick this, like I told you earlier, you know how I said if a number has 33, you want to pick a 3 and an 11? Here I'm dealing with a divided by 3 issue. So I pick a number where the sum total is 33. So it is easily divisible by 3. So -1 plus 0 plus something should be divisible by 3. So I picked the number 34 because when I add in the -1, it becomes 33. So in this case, with my second set of numbers, A is equal to 33 divided by 3 equals 11. B is equal to 0. Which is bigger? A. So now, we've figured out 2 possibilities. Well, if sometimes the 2 are equal and sometimes A is bigger than B, what's the right answer? Clearly, the answer is D, right? I always tell you that if it's sometimes this and sometimes that, the answer is always going to be D. And there you've got your answer. This is a 62% of people got it right kind of question. Therefore, I consider this to be easy medium. All right, let's move on to the next question. And that is question number 4. Feel free to pause now, read it on your own, and spend 2 to 4 minutes working on the problem by yourself. I assume you've now restarted your video. Let's talk about it. So here your given information is a graph, is a diagram. You must analyze and understand the diagram fully before you dive into quantity A and quantity B. So what do we know about the triangle? I'm going to ask you that question. What do you know about the triangle? You should pause and answer it. After pausing and answering, you probably recognize it's a right triangle. You also recognize one is 50 degrees. One angle, interior angle, is 50 degrees. So therefore, what is the other interior angle? Clearly 40 degrees, because all three must equal 180. So 90 plus 50 plus what equals 180? The answer is 40. So then the question is the opposite side of an angle. If the angle is smaller, does that make the opposite side smaller too? Or does that make the opposite side bigger? Well, that's a tricky question. And so what we do is we expand the range to make it easier. So I've written down in my bullet point 2, how can I stretch the range to make the comparison more obvious to me? So instead of comparing 50 to 40, let me just compare something like 100, right? If I have a big old, or sorry, not 100, that's too big, because all three angles must equal 180. If I do like, 80 degrees, that's super big, right? But it is still less than 90. So I do 80 degrees. Well, if I examine and think about my triangle, and in my mind, or even on paper, I draw out a right triangle with that 80 instead of 50, where the 50 is, I'm going to notice that X gets super, super big. And I'm going to notice Y gets super, super small. So all of that is a way of saying X gets bigger as the interior angle opposite of it gets bigger. So now that we know that, my question to you is, which side is bigger, X or Y? You should know that the answer is X, because it is opposite of a 50-degree angle. Y is opposite of a 40-degree angle, therefore is smaller. So now we know X is bigger than Y. Let's go into quantity A and quantity B. B is set at 1, so it's really simple. Quantity A is not, it has variables. But knowing that X is always bigger than Y, what does that tell us? And of course, X and Y are both positive numbers because they cannot be negative. They are part of a diagram, a triangle. So if X and Y are always positive and X is always bigger than Y, what is that ratio? What is that fraction? Is it bigger than 1 or smaller than 1 or equal to 1? The answer is it is always bigger than 1. Now that should be obvious to you, but if it's not, you can always pick easy numbers, just like I said in my strategy number 2. If you were to pick easy numbers, you would pick something like X equals 2, Y equals 1. What do you get? Quantity A is 2. That's bigger than B, which is 1. And then you want to extend the range. What if you pick the quantity of X as 101? Y is 100, right? You would end up with a quantity A of 1.01, just barely bigger than 1. And quantity B will still be just plain old 1, which is bigger. A, it's still A, it's always A, therefore always, always A is the answer. It's not sometimes, sometimes. That's how you analyze question number 4. We're moving at a rapid pace because, again, I'm assuming you're able to pause the video. So now we're on question number 5. Please pause and answer this question on your own, given your time restriction. And now I'm going to answer it for you. So our given information this time is a little bit different. It is now illustrating that 0 must be less than X, must be less than Y, must be less than 1. So again, you have to take your brain and chew on that information, understand it, soak it in. What is all of this saying? What is all of this really meaning? Okay, you have to interpret the given information. So when you interpret it, what you see is that X has to be a number not 0 and not 1, but somewhere in between. It's got to be a fraction. Same thing with Y. It must also be a fraction, a less than 1 fraction. And then X must still be smaller than Y. So Y is going to be bigger than X. So those are all the things that you should be thinking about. All right. Fractions are also known as, in decimals, it's going to be something at a 0 point something level, right? It's less than 1, but higher than 0. It's going to be 0.01, 0.9. Those things all translate to fractions. But I like to, in my bullet point number 2, demonstrate to you that they can be positioned as numbers between 0.01 approximately to approximately 0.99. Now, we do what I explained before. We pick easy and helpful numbers. Let's start with a super easy number. X is 1/4, Y is 1/2. I've put it in numeric format just to make it easier for you here. So if I do it, go ahead and do that. I come up with an A, a quantity A equal to 0.5, and I come with a quantity B equal to 0.25. A wins, yay. So A is bigger, okay. Now that we've shown that A is bigger, I want to be able to try to break what just happened. I want to show how B might win. Because if I can prove that B can sometimes win, then it's sometimes A wins, sometimes B wins. The answer is, you guessed it, D. So if I cannot break it, then I'm convinced that in fact it's always A. But what I'm trying to do is break it, because if I try to break it and fail, I know it is break proof, so to speak. All right, so what I'm going to want to do is test a Y that is very small and test a Y that is very large, and then see what happens. So again, I'm going to recommend my final bullet, diagram. Use your scratch paper. Do the work on paper, because if you can't visualize and draw it out, it's going to be much harder to do in your head. Very, very hard to do in your head. So I do not recommend that at all. All right. So for example, if you picked a Y that was very large, say you picked a Y of 0.9, all right, and then you picked an X of 0.5. Well, quantity A is 1 minus 0.9, which equals 0.1, which is very small, right? 1/10. And quantity B would be 0.9 minus 0.5, which is 0.4, which is 4/10, which is a little bit bigger. It's almost a half. So in that case, quantity B is bigger than quantity A. And there you have proven that it's sometimes A and sometimes B. The answer is D, like dog. Now, the percentage of people who got this question right is 47%, making this a medium difficulty question. All right, I got a couple more questions for you before we end our hour-long session. But this next one is question number 6. And you start off with the given information that P is the probability that some event E is going to occur. S is the probability that that same event E will not occur. Notice we're talking about the exact same event because it's the same letter E. So P is the probability it will happen. S is the probability it will not happen. Now we analyze the A's and B's. So things to think about. What do we know so far? We know that P plus S equals what? It equals 1. Because the probability that something happens, like, for example, I'm a basketball fan, so probability that the Warriors win might be 70%. The probability that they lose, that they do not win, which is S, is going to be the opposite of it, meaning 100% minus the 70%, it will be 30%, right? So if the probability that event will happen is 70%, the Warriors win, then the Warriors not winning is going to be that other 30%. The total of the two must equal 100%, also known as 1.00. So we know that P plus S equals 1. Now, that's very important because now that we jump into the question, quantity A is asking us directly, what is P plus S? Well, as I just told you, it's equal to 1. So we know that information because we analyzed the given data, the things we know, starting with what we know, we analyzed that enough to understand that P plus S must always be 1. Now, P times S, that's going to change quite a bit, right? So now you pick different options, right? So now we're into my bullet point number 2. Pick helpful numbers. If I picked a P of 0.1 and an S of 0.9, meaning 10% Warriors win, 90% Warriors don't win, then my B value, the P times S, is equal to 0.09. And that's just, you got to do the math. You got to punch it in your calculator. You got to do it on paper if you're super smart and super good at math. But you got to do the work. Use the online calculator if you need to. So now I've shown how A is bigger than B, because 1 is obviously bigger than 0.09. Now I want to flip-flop it and see if I can show how, in fact, B might be bigger than A. So I'm going to flip-flop I'm going to create a huge range, right? We talked about range. Instead of P being super small, like 10% chance the Warriors win, I want to pick a P that's super big. Now I'm going to pick a P of 0.8 to where it looks like the Warriors are going to win 80% of the time, and they'll only not win 20% of the time. This is my bullet point 3. P equals 0.8, S equals 0.2. That gives me a B value of 0.16. Again, simply doing the math on a calculator or on paper or in my head. And that still results in A being bigger than B. So now I've picked 2 different sets of numbers with a great and wide range, but I still come up with A being bigger all the time. So the right answer is A. All right, this question is a 36% of the people getting it right. So I would consider this to be medium hard. Okay, medium hard. All right, let's move on to the next question. Go ahead and pause and analyze it yourself. Give yourself between 2 to 5 minutes, and then click on play when you're ready to resume. I'm now going to analyze this particular question, number 7. The given information is X and M are positive numbers, and M is a multiple of 3. All right, we're given that information. So immediately, before I even look at quantities A and B, I'm already starting to think about what numbers could these be. So X can be any positive number. So I'm thinking 1, 2, 3, all the way up to 1,000, right? M can also be any positive number, but it must be a multiple of 3. So what could M be? What are the possible range of values for M? These are the things you need to be thinking about. So the lowest value M could be is the number 3. But M could be as high as, of course, 300, 3,000, 3 million. But again, we want easy numbers to work with. So 3, 6, 9, 12, 300. Those are all pretty easy numbers. So I'm already analyzing what could be the values of X and M. Next, I'm going to look at the question, and I'm going to notice there's exponents, there's dividing. These are good things to know. I should know that X to the M power divided by X to the 3rd power is the same as X to the M minus 3 power. But if you didn't know that, that's okay. Don't worry about it. So now I'm going to pick numbers that help me. Of course, the smallest numbers I came up with is what I'm going to start with. So my X, the smallest number I could think of is 1. My M, the smallest number that I could think of is 3. I'm going to plug in X equals 1 and M equals 3 and see what my quantity A's and quantity B's give me. So once I plug that in, quantity A is X to the 1 power divided by X to the 3rd power, also known as X over X to the 3rd. That's going to be equal to X to the minus 2 power. Then if I plug in the M equals 3 into the quantity B result, I get X is M over X to the M over 3 is X to the 3 over 3, which is X to the 1st power, which is simply X. And I'm sorry, I made a quick mistake. Quantity A actually is X to the 3rd divided by X to the 3rd. Sorry about that. And so again, X to the 3rd for quantity A divided by X to the 3rd is equal to 1. And quantity B, X to the 1st power, when X equals 1, 1 to the 1st power is equal to 1. In short, if you simply plug in and do the math, you will find that quantity A is equal to 1 and quantity B is equal to 1, given an X equals 1 and M equals 3 variable range setup. So they are equal. Now that tempts me to answer choice C, but I am not prepared to do that, right? Because I have not tested the range of values. So now I'm going to test the range of values. The beauty of having found an answer that gives me a column A and column B being equal is that it is really simple to break. We talked about breaking the system. It's really easy to break it because all you need to do is find anything where A is bigger than B or B is bigger than A. So it's really simple to break something where they're always equal because it's just there's so many more possibilities to not be equal. So I pick just anything. I don't even go for too deep of a range because it should be easy to break. I simply pick the next two numbers, x equals 2 and m equals 6. And when I plug those in and I do the math, which I'm going to let you do by yourself, I come up with a quantity A of 8 and a quantity B of 4. That's interesting. So in this case, A is bigger than B. So what's the right answer? Is it C? They're always equal. Is it A? A is always bigger than B. Do I need to test some more to see whether sometimes B is bigger than A? The answer to all of those is no, no, and no. You should know by now that if it's sometimes this and sometimes that, the right answer is answer choice D like dog. And that is the correct answer here. This question has a 34% correct answer rate. Therefore, I consider it to be medium hard in case you're wondering how you stack up against other people. All right, now I'm going to go through the last question I have for you. And so again, pause the video, give yourself a few minutes to work on it, and then come back to me when you're ready to hear my explanation. All right, this question says that a random variable y is normally distributed with a mean of 200 and a standard deviation of 10. All right, now we're getting into standard deviations and distributed curves and things of that nature. You don't need to know all there is to know about standard deviation, but what you do need to know for the GRE is basic plotting of a normally distributed curve and basic understanding of standard deviation. So, all right. And I've put that in bullet point number 2. The GRE will test you on basic standard deviation. My bullet point number 1 talks about understanding the given info. I always recommend you do that. So the mean is 200, the standard deviation is 10. What does that look like? Draw it out. I always recommend you draw it out. Now, if you know what I'm talking about, if you understand everything I've said, you can probably draw this, no problem. But if you're confused, let's jump to my bullet point number 3. I recommend you draw a bell curve. That literally means draw a line and then draw what would look like a bell. It starts small, it gets bigger at the very top, and then it gets smaller again as you go down. It looks like a funny hat from people in England who were in Parliament in the 1800s, right? Looks like a wig or something. And you can, of course, look this up on the internet very easily. What does a bell curve look like? But now that you've drawn your bell curve, you have to understand some basic concepts. The first is that you find the midpoint. Okay, that would be also the mean in a bell curve. That's not always the case, but in this case, the mean is the midpoint. So you find that midpoint where the kind of the hill is the highest, if you will. Within one standard deviation to the left and to the right of that is a set of information or data that, meaning the colored portion, if you were to color in the hat from the bottom line to the bell curve, 68% of that shaded in hat is located within one standard deviation to the left and to the right of that midpoint. And then within 2 standard deviations, 95% of the data is enveloped within 2 to the left and to the right. So that's a great way of saying bunching. How much does it bunch? Well, it bunches very much within 2 standard deviations. So 70% of your data has to be within 1, and 95 has to be within 2 if it is a normally distributed bell curve. So write it out, draw it out so you can see it, or Google it, look it up on the internet so you can see what that looks like. All right, so now we look at our question. Now that we've understood everything we need to know before we launch into A and B, now we're well prepared to attack the question. And the question is this. Quantity A is equal to the probability of the event that the value of y is greater than 220. And quantity B is simply 1/6, roughly equal to 16 or 16.6% with a line on top, right? 16.6 to eternity %. So what's bigger, A or B? Is A bigger, the probability that value y is greater than 220, or is B bigger, 16 to 17%? Well, obviously we have to break down quantity A. What is the probability of the event that the value of y is greater than 220? Well, we know the mean is 200. That's the midpoint of your bell curve. We know a standard deviation is 10, so you kick it over to the right by 10, makes it 210. But you kick it over a second standard deviation, add another 10, you make it 220. And you know that within those two standard deviations, 95% of the data must reside there. So quantity A is saying, what's the probability that is to the far right tail end of this little wig that we created? So if 95% is inside of two standard deviations, what will have to be outside of those standard deviations? The answer is clearly 5%, or 2.5 to the left tail end and 2.5% to the right tail end. So quantity A is actually roughly 2.5%. It's very, very small. Quantity B is 16.6%, relatively large compared to that. So what's bigger, 2.5 or 16.6? The answer is B, all the time, because we actually calculated numbers. So the answer choice is answer B. All right, this question is a 46% correct, answered correctly question, given the general population. So I would consider this to be a medium difficulty level question. So the beauty is, not only have we talked about the questions and figured out how to answer it, I've hopefully helped you identify whether you're good at just the beginning questions, whether you're good at the beginning and medium questions, or whether you're good at even the beginning, medium, and medium hard level questions. It kind of gives you an approximation of where you are in understanding quantitative comparison. So with that, I'm going to end today's session. I hope it was very valuable to you to take a deep dive, a 1-hour session into quantitative comparisons and really help you to understand them better because they are so unique and they're so different. Now, keep in mind, that's only one part of quantitative reasoning. You are going to have these standard questions with A, B, C, D, E, standard multiple choice answers. That's going to be in your test as well as some other formats. So keep that in mind. I haven't done a comprehensive review of math, but I really wanted to get into the stuff that truly is the very hardest to understand, which is that quantitative comparison piece. So with that, I'm really hopeful that you've gained a lot from this, that you've understood better how quantitative comparisons work. Always keep in mind those 4 strategies. Start with what you know, number 1. Number 2, pick easy numbers to help you work with. Number 3, always choose a range of values when you're trying to work with possible values of describing what could be higher, A or B, or equal. And finally, number 4, making sure that when it's sometimes A, sometimes B, or even sometimes C, sometimes A or B, you can immediately go to answer choice D being your correct answer. It cannot be determined with the information given. So with that reminder of the top 4 things to remember strategy-wise, I'm going to close out today's session. Thank you again for joining me, James Powell, for this session on the GRE, and best of luck on the test.